welcome to today's show. One of my viewers asked me if I could create a video about coding a tool which changes your MAC address. And that could be a quite useful tool, because sometimes when you are connected to your internet service provider, for example, and maybe you take your laptop to your neighbor and you're both connected to the same switch in the basement, and then you might the MAC address might get locked to your neighbor's switch port, and you can't use that computer connecting to internet at your own home until it expires in a couple of hours. In that case, it could be nifty to be able to change your MAC address temporarily in order to regain access to the internet. So that's one legit purpose of that kind of tool. And I have not prepared this episode in any way, and I don't really know how to code a tool like that, but I have an idea how to find out without using any Google. So that could be a useful lesson on its own in case I succeed, how to figure out how to do such a thing when you don't know how to really do it. Alright, so let's call this tool alter MAC, because it will alter your MAC address. I will use VI today because I am doing this on my 32-bit virtual machine, and it's a bit tricky to connect to that server through Sociopath as I usually do, because it has a local IP address and I'm not local to that network. So, well, it's possible I could tunnel, or I could create some network address translation entry and such, but I don't really want it directly connected to the internet. So let's just code in VI today. And I think this tool will be quite small, not a lot of lines of code, but we'll see how it'll turn out. So let's see. Let's create one additional window, and let's go to code and go to C and go to alter MAC, and I will set my home to my current working directory as usual. So I will code in one window and try the code in another. And let's see. I think I will do everything in one C file today, and I will simply call this altermac.c. And I will begin, as I usually do, with a simple header like altermac.c. I will do my different includes. The 4 that I almost always have are these ones. And stdlib.h, and I do also want to have the R number, and what's it called? Let's see. I want to assert. That's the one. And maybe we should have this order. And I also need to define the GNU source constant in order to get the assert PRO function. Alright, so let's begin by defining a couple of data types, as I usually do. I want to have let's see, an unsigned char, which will be int 8. I want to have a unsigned short integer, which will be int 16. and I want to have an unsigned regular integer, which is int32. I'm also going to create a structure which will hold the MAC addresses. So let's call this smac, and it will only contain one variable, and that would be an unsigned long int, or maybe we should make that as well. Let's type def unsigned long int, which will be int64. So let's make this int64, and we will simply call this address, and I want to use 48 bits because a MAC address is 48 bits long. So that's why I define a structure even though I only have one variable in it. That's so I can limit this to just 48 bits instead of all the 64. And I also create a type definition for this. So struct smac will be called mac with a capital M. And that's basically the different structures and types. So what kind of functions will I have? Well, we will have a main function like usual. And do we need any arguments? Possibly. So let's do it like this. And I need a function which generates a random MAC address. So let's call that, it will return a MAC address, and let's call generate MAC. And we don't need any arguments to this one. And that should be enough for now. So let's see, let's begin by creating this generate MAC function. So, or let's start with the main, by the way, because I want to seed the random number generator, and I'll seed it with get pid, so we get a different seed every time. Turn 0 like so, and that'll do for now. And we will create our generate MAC. And let's see how we do it in the best possible way. Let's check the random function, what it returns. It returns a long, okay. And I want to fill out as many of these bits as possible. So if I just generate one random number, then it might be a lot of zeros in the beginning, possibly. So I will solve this by creating two different numbers, a and b, and I will set a equal to the long version of random, like this. I will set b equal to the same. So now we have two possibly quite big random numbers. So let's see. So we need a 6-byte number. Right. So let's create a MAC. Let's call it MAC. And we want to set the MAC address to, let's say, a times b. And then we want to do modulus modulus 6. So let's see if I... No, wait a minute. Here we want to put the highest possible number. So basically we want to do 2 to the power of 48. And that's not it. This is the right one. So this is correct, I think. Let's put it right here. So this will generate a number between 0 and this. And then we will simply return this number by doing return mac. Before you couldn't return a structure like this, but now you can do that. Perhaps we should create a really simple make file so we can add some options. So let's have options, and let's have O3 and wall and standard equals the latest one, which is C2X. We will have a, let's see, it's called altermac.o depending on altermac.c. And we want to run cc with the options, and then -c and the source. Then we want to compile the actual binary, which will be called altermac, depending on altermac.o, and we'll run cc with the options. We'll take the source and output to the destination. I also want to have a clean, like I usually do, which will remove the altermac and all the O files. And finally we will have the all, which will run clean and then altermac, like so. So if we run make, let's see, width of address exceeds its type. Int 64. Okay, I'm on a 32-bit machine, that's probably why. Let me try something. Let's comment this out and this too for the time being, and I want to print the size of int 64. Int 64 undeclared, what did I call it? I did it with small numbers, alright. Okay, it wants the parentheses, I guess. Yeah. Alright, so if we run this, will it give us a 4 back or an 8? A 4, okay. So an unsigned long int is just 32 bits on my system. So let's do a double long instead. Now it's 8. Right, so let's put this back. And let's remove this and this and this. Let's see if it compiles. Conflicting types. Alright, I didn't give any arguments. So let's do that. We will have an int argc and a char argv like this. Now it compiles. Alright, good. So let's see, let's try this generate Mac function. So let's create a Mac and let's set it equal to generate Mac, and let's print it for now as a hexadecimal value, and maybe we need to have lx here. Let's try this Mac address. Lx expects argument of long unsigned int long. So what will it be then? Double lx perhaps? Never actually used that. No. Man free printf, search for long ll. Alright. What does it say? Unknown conversion type character in format. That's a little bit weird. 0x %ll man3 printf long ll. The following integer conversion corresponds to a long or unsigned long argument, or a following so it should be LLX then. Didn't I have that from the beginning? Or did I switch the order? LLX expects argument of type long unsigned int. Argument 2 has type long unsigned int 48. Alright, so it's... let's just do this then. Probably we'll pad it with zeros, right? Okay, no error. And let's run make. No, let's run automac. And we get this. So if we turn this into a MAC address, it will be something like this. If we do the Cisco format, and if we do the Windows style format, it will look like this. So it seems to be working, and if we run this several times, we get completely different numbers, right? Yeah. Okay, so now we can create a MAC address in a numbered format, but possibly we need it in a string. And we might also need to convert between a string and a number. Or maybe we shouldn't get into that before we know how to actually change our MAC address. So my thinking is like this. There is a command in Linux for changing the MAC address. So let's utilize strace and possibly ltrace in order to try to figure out what system calls and stuff that command will do. And then we try to mimic that in a way or two. So let's see. We will use the ifconfig. And let's see. Our Ethernet address is this, which is a MAC address. So let's see if I remember how you can change it using the command line. Let's become root first. And do I have access to ifconfig without the full path? Yes, I do. Alright, so first it's the interface, and then it's something like HW address or something like that. So let's try to change this, and let's just change like the ending to, I don't know, EE. No, that's not it. List of possible hardware types. Interface address HW here, HW address. Okay, so what if we remove the address part and just do this? No. Let's check the manual for ifconfig and let's search for HW. Class address. Okay, so it needs to know that it's the Ethernet address that we're changing. So HW and Ethernet. No. Still didn't like that. Or maybe just Ether. There we go, okay. So let's see if it did change. Yes, it did. Great. So that was quite easy. If we were lazy, we could just, in our tool, call this this command using like execl or execv or possibly even system. But we are not lazy. We want to know how this works under the hood. So let's simply issue this command. Let's change it like this. And we want to use strace and follow potential forks. And we want the standard output to a file. So let's call this output.txt. And let's open this with our VI. And let's go to the ending and check from this part. Okay, so here we have an ioctl command. This is usually used for doing similar things. And a parameter to that is SIO SIF HW address, hardware address. So this is probably the right thing. And we give the interface name. We give some kind of a structure containing that it's the Ethernet address, and then we give the MAC address like so. So how do we exactly mimic this thing? Well, if we go to the man page of this system call, no, not that. Let's see if there is either a list of things or somewhere pointing us into the right direction. Or out parameter, and the size of the argument, macros and defines used in specifying blah 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 are located in the file sys ioctl.h. Let's check this one, but first let's see the syntax of the actual command. Okay, so we need an fd, file descriptor, we need a request, and we need a, which is a constant of some sort, and we need possibly additional arguments. So let's begin by checking user include and this file. Okay, that did not exist. User include sys. So let's go to user include and let's find ioctl.h. Okay, so this is probably the correct one in this case. Your is probably i686 because you are running on 64-bit, I assume. Alright, so let's see what this file contains. Not a lot, actually. Does it include anything else? Features.h, bits ioctls.h, get the list of ioctl requests and related constants. Alright, so that's probably it. So let's go to bits and ioctls.h. Alright, now we're getting somewhere. So let's see, what did we... Let's open our output file. Where am I? Alright, I put it in the root home directory, I think. Yes. ctl. This is the one. So we are looking for this one. Okay, set hardware address. Alright. So let's save this one by doing... let's just create a window and do this. But what about the other parts of it? We obviously need some kind of a structure. IFR name. So what if we... Let's see. Where were we? Here. What if we search this file for that? No. If we grep, let's do this search once again, and let's cat all of these and grep for this name. No. Okay, let's search for this in here. Linux if.h, definitions which begin with ifr name, define ifr name, ifr blah blah blah, interface name. ioctls must have parameter definitions which begin with ifr name, blah 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 blah, interface name. What if we go into this file and search for it? Where are we? There. Okay, so here we have something called struct ifrec. Does this correspond to what we're looking for? Yes, it seems like. Address, destination address. This seems to be pretty much the right one. So let's see, ifr name, ifr hw address, yes, this is it, and sa family. So what is this? Is a sock address. All right, so hw address. Okay, so let's start by defining this one then. Do I still have a window with the code? No, I don't. Let's copy this whole line. Put it here. And then we close down this one, go back to our stuff, and let's open our altermac.c. Let's create something like bool change Mac, and we'll give it a MAC address. Now we need to add the std bool.h, and let's also add the other ones. So let's see, for the actual system call ioctl we need this one, and I think this will include all the other stuff in turn. And for this structure we needed, let's see if I remember it right, it's net.if.h, I think. Let's do something like ps grep vi. No. ps grep vi. Net.if.h, yes. So now we have the includes. Let's create our function, and it's a bool change Mac, and we give it a Mac of Mac. And we need a struct if request, let's call it ir, and we need to set the ir dot something. Let's go to this, and ifr name. And how does this look? ifr name is a union, which is called this. So that basically means that we need to include that as well. So this dot this, and then the ifr name. And this is a regular string, so we need to do the str string copy into this, and we need to figure out our interface. Let's put it like this for now. And how much do we copy at most? This one. Let's do this -1 to be sure. Alright. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, welcome back everyone. Let's see if we can tie up the bag, as we say in Sweden, when we finish some project. Alright, so where were we? We were about to prepare this ifrec structure. So we are copying into this string variable. We are copying the interface, and we need to supply the interface. So let's just send an int 8 if, and let's also alter the signature of this function. And while we're at it, let's go to the main and create a simple usage. We can edit that later on perhaps. So if argc is less than 2, what do we want to do? we want to fprintf to the standard R, and the usage will be the binary name followed by the interface using this new capital standard. And we give it the first argv, and then we will return -1 like so. And let's also create a pointer. Let's call it int8 int8 if, and we'll just do this. If is equal to the argv1, and we probably need to cast this as well, like so. And then, alright, let's finish this generate the change mac function. So now we can let's see. Now we can change this to the if. Alright, so that's the first part of it. So we have this. Now we need to set this if hardware address. And what is that? That is a sock address. Alright. And the sock address is just the same as we let's see, sock address. Yeah, that's what we usually do when we create TCP connections, right? So it's got a SA family and an SA data. So let's create this sock address. Or no, this is not a pointer. Alright, so we can probably, let's see, this is a union, so it will only take one of these. Alright, so let's see, we will set the IR dot this followed by this one, and then we need to set the contents of this one. The SA family will be set to this, and we'll use this ARP something either like this. Alright, okay, so let's continue. We have set the SA family to the ARP something either. And what's next? Now we shall set the hardware address, this SA data field, and we're gonna set it to the MAC address. So let's see, the SA data, what kind of a structure does that have? SA data, and that is inside of the let's see, it's inside of the sock address, and it seems to be a regular string. So we need to convert our MAC address to a string, and I suppose this is the correct format. And that's basically the only thing left to do. So let's see, s_data, So we are going to copy into the ir.ifr ifru dot and this sa data. So into that variable we're going to copy something, which remains to be seen what, and how much do we want to copy at most. So let's see, we don't really have a size of this thing, do we? No, this is not it. Where is the here is the HW address. And if we look at, oops, let's see, no, this is not it either. Okay, there we go. So where did I put the man page? Here. Yeah, it's a variable length size to this one. So let's use the longest possible MAC address. So what do we have? We have, okay, let's use this here as well. We have 6 different fields with 2 bytes each. That is 12. And then we have 1, we have 2, we have 3, we have 4, we have 5 separators. So that is 17, right? And then we have a 0 byte. So let's say 18. Like so. And when we have prepared the structure, we need to call the actual ioctl. And if we do man to ioctl, we will have first the file descriptor, and in our case it uses a 4. Perhaps we need to open some file first. Let's see, where did we put this? Text file we made. Alright, so let's go to ioctl, and this is the 4. So somewhere we will probably have an open. No, okay. We will open a socket. It's this one. Must be right. So let's do that first. And in order to, oops. In order to open a socket, we need a file descriptor, and we'll set fd equal to this. And we assert that we have an fd which is more than 0. Okay. And the only thing we need to provide it with is this constant, and then as the only argument our structure. And it should return 0. So we want to run, let's create a file descriptor for the return value to make it a little bit more expressive. So ret will be equal to ioctl with ctl with our file descriptor, our constant, and our IR. And then we close fd, and if, let's do like this, return, and if the return value is 0, then we want to return true because it has succeeded. Otherwise we'll return false. And that's basically it. Okay. So now we have basically all the different building blocks. if names, I think there should be an E here. So the only thing we need to do is take our 48-bit MAC address and make it a string out of it. So let's create a function and let's call it, but wait a minute, let's add a temporary thing. And let's see if this compiles as it is right now. So we don't need to troubleshoot a wide range of different stuff. Make clean, move down a little bit, clear, and make. And let's see. Expected a semicolon on line 38. Here. Bool change MAC int 8 if MAC. Is it okay? It collides. What is this int 8 if then? Nothing, it seems. Okay, it still doesn't quite like it. Okay, it's called if, and that is a restricted thing. All right. So, what did I do now? Let's search for if, and here's one. Let's call it if with a capital I. And this we don't need to change. That. And this should be if with a big I. And we never defined this thing. No, it shouldn't be char, it should be int 8. And int 8. Okay, that's better, I think. Make clean, clear, make. Oh, right. Let's see. Probably a couple of includes, right? IP proto IP undeclared. So if we check the man page for socket, it should be syscall syssocket.h. Do we have this? Is it still undeclared? IP proto IP. If we check some of the related ones, this also needs connect. What about bind? Listen. All of them just says syssocket.h, but there is something called inet or something like that. What if we check for in address t, also syssocket, and sock address in. This one, I think. Okay, that error went away. What about this? We didn't change this line, so 49. This should be if like this. And this should be without the, okay? What about this? It wants an unsigned char. And what did we give it? We gave it an int 8, alright? So this should be a char like this. And let's see, this should be okay. And this is currently a char. Let's cast this anyway because I'm gonna have a different type later on. Okay, let's check this again. Alright. It didn't find this ARP header thingy. Where did we find it? Let's see. I think we search for, was it ifrec? No. Sock address perhaps. And let's see, sock address in. Do we have this, by the way? And no, not that one. Let's try this. Nope. What if we were to grep for this thing inside of user include? Then we find it inside of netifrp.h. Is this a file that we should include directly? I think so. So netifrp.h. Variable if set but not used. That's in 64. So what is this then? Okay, we said it, but we never. Right. We haven't called that function yet. So just to get rid of the warning, let's remove this. And okay, now it's undeclared. Let's do this instead. Void if like so. String copy offset, and this annoying thing again is out of bounds of the referenced subobject. So how are we supposed to use this one then? Perhaps we need to allocate it dynamically. So let's see. This is a sock address. So let's define a pointer for that. Struct sock address p. And let's do something like this. Int 8 and let's just call this address. Let's remove this, and after we have the socket we wish to calculate a size. So int 16 size, and the size will be equal to the, let's see, the size of a struct sock address plus the int16 representation of string length of the address. And then we can allocate our p. Let's add a little bit to it, by the way. One extra. P will be equal to the struct sock address of malloc, and it's this size, and we assert that p is not 0. And let's see, SA family, SA data. So we will set the p as a family to this, and we want to string copy to p as a data, and we want to give the address, and the size will be size -1. And then we will set this whole thing equal to p. And after we have called this ioctl, we can free the p. And let's for now just set the address equal to an empty string. And let's see if this works. What does it say? Pointer target in assignment, blah blah blah. And this is 48. Alright. we need to cast this as well. I will try this again. It still differs in assignments. Why is that? Pointer targets in assignment from char to int8. We went the wrong direction. This is correct. And this is also different in signedness. In 16 we need to cast this to a char. And finally, incompatible types when assigning to type struct sock address from type struct sock address star. So that is not a pointer, right? But how can we use that string otherwise? Well, let's do it another way. So let's make this whole ifrec thing pointer. But that won't cut it, I guess. Can we just, instead of copy, let's see, remove this P and yeah, let's remove all of that stuff. So let's get rid of the size, the P, the assert, and we'll go back to what we had before. So this thing, ifr name dot no string copy to ifr name it shouldn't be ifr name, it should be let's just delete this entirely. And let's take, no, not that one, this dot sa family is equal to that, and this, let's do this the other way around. So let's say we set the ifru hardware address dot sa data is equal to the address, and then we need to make this into a regular char, I suppose. This should be possible, right? So this SA data needs to go. So now we have the family. What was this? Yeah. Right, this is the interface. So we have the interface, we have the family, we have the SA data as a pointer, and this we don't need anymore. Alright, let's see what happens. Assignment to expression with array type, but how are we supposed to put something in there? Because we have this, and then we have an array, a variable length array of char, and that's the end of the sock address. So how do we put anything in there? Maybe we have an example. Sock address in 6. What if we were to assign the values at declaration? So something like this is equal to .sa family, and this, and .sa data is equal to this. Is that possible? Maybe. Let's try it out. No, not really. And I suppose we can't just do, no, can't. So what if we were to define this ourselves then? This is a sock address in, and we copy this thing. But that won't help us either, because this is inside of the other one. In the middle of it even, right? And where was that? Struct ifrec. netif.h. Okay, so this is our, what about this? Define hardware address length, and if name size. Hardware address length is 6. That's 48 bits. Interesting. It should not be a string then. It should just be defined as a string, I suppose. IFR, IFRU, IFRU. Hardware address. That is the MAC address. So what happens if we simply copy 6 bytes into it then? I'm not sure about the order, but let's just do from left to right. So that would mean we don't need this string conversion method. That's kind of good because we waited until last with that, and it seems it was a good decision then. Alright, so let's see. We will not do this like this. We will go back to this way. So the hardware address SA family will be equal to this. And we will, let's see, it might contain null bytes. So let's mem copy towards this. No, not that. This dot s. Very weird with the copying tray. HW address dot SA data. This is the destination, and the source is, well, we can just do we need to have a pointer here, right? Let's set P for now as 6. And let's create a char P, and we set P equal to char star of Mac. Can we do that? Or let's not go around the water for water. Let's just put in the reference to P. And 6, and then we can remove all of this. Let's see what happens. What does it say? P undeclared, that's right. It's not P. It's Mac. Maybe we need to cast that as well. No? now it compiled. Interesting. And what happens if we run this thing? Let's check our current MAC address first. This. And let's just see. But we haven't called our function yet, by the way. So change MAC, it takes an interface and a MAC address. We generate the MAC, we print it out. But before we print it out, we want to do if change MAC interface MAC, then we print it, else then we just do assert p error number. I think that ought to be enough. Alright, let's see what happens now. Make clean, move down a little bit, we make, and if we run this as non-root, right, we need the interface, and the interface is what? ENS192. And let's save this MAC address. I'm not sure if I did that, like so. Then we run alter MAC ENS192 bad address. $977. Okay, so change MAC returns false. Let's run it with our strace. Get an e-fault, bad address. Okay, it's probably this. Ah, we're sending the value, alright. So, where is it? ioctl. Let's send the reference to this instead. Operation not permitted. Alright, that was what we're looking for. So if we run this as root instead, and then the entire server crashed, or the entire network. Not my internet connection anyway. Okay, not the entire network. Maybe just my SSH connection then. This is 17. No, let's do this instead. Kill all SSH. And let's reconnect. Something happened with the server. Either it got disconnected due to the MAC change, or the MAC, it's trying to chain smack in the wrong way, made it somehow disconnected from the network, or the whole server kernel panicked due to a buffer overflow because I sent the wrong arguments. Alright, I need to try to get back into this server and see what went wrong. But we are almost done with this tool, only a little bit left. So, as for now, we will be... This will be all for today, and I will check out this server and see what went wrong. Probably there's just some minor change to the code which will actually make it work. So thanks for watching, thanks for today, and please like and subscribe if you like this episode.